All right, so here goes the 2 examples on an angle. So this is probably going to be kind of a long video, which I don't like, but okay. So I didn't work these out first, so hopefully, I can go through the thinking process and you can sort of follow it, okay? A golfer on a fairway is 70 meters away from the green, which sits below the level of the fairway by 20 meters, okay? So the green sits below. Okay, so here is the launch point, okay, and then here's the green. All right, by 20 meters. So this is 20 meters, and it is 70 meters away. All right, if the golfer hits the ball at an angle of 40 with an initial speed of 20 meters per second, okay, so he's going to hit here. My V naught is 20 at an angle of 40. All right, how close to the green does she come? Okay, so we're really looking for the delta X, right? Because 70 is kind of not a given. That's sort of something we're going to compare to, okay? So the very first thing I want to do, even before I start writing my variables, I think, is I'm going to split my components because I know I'm going to need to do that, okay? So my V naught X is going to be V naught cos theta, which is going to be 20 meters per second cos 40. Okay, which is going to be, come on, calculator, 20 times cos 40. Yeah. 15.3 meters per second in the X. And then in the Y, sine 40. 20 times sine 40 is 12.9 meters per second. And just round that, okay? Don't keep like 100,000 numbers. Okay, all right, so now I'm set. So now I'm going to go ahead and make my list. That would be the next thing that I would want to do. And you want to always split your list up. Okay, so my delta X, right, that's what I'm actually trying to find. Because the 70, remember, I think that's just a reference so we can decide if she makes it or not, okay? The time is unknown. The V naught X is 15.3, okay? The delta Y now, okay, so now I got to make a decision about direction. So I'm just going to go ahead and set up as positive and right as positive. Okay, so my delta Y is going to be negative 20, right, because it's going down. My V naught Y is going to be positive 12.9 because it's facing up. My A is going to be negative, I guess I'll just use 9.8 because WebAssign does. Okay. And let's see, what else do I know in the Y direction? Anything else? No. And I'm probably going to need to know the time, right? Because the time always is going to be needed, all right? Okay, so now I'm ultimately looking for delta X, okay? But I can see that I don't have the time, and without the time, I can't do that. That means I need to start in the Y direction, all right? So I have delta Y, V naught Y, A, and T. So I'm going to use... Oh, this is so ugly. I guess I'm going to have to use this one. And then I'm going to have to quadratically solve it, which I realize I forgot to teach you for free fall, but I'm sure you figured it out. Okay, so this is going to be kind of a hassle. So negative 20 equals 1/2 negative 9.8 t squared plus 12.9 t. Okay, so whenever there's an initial y velocity or an initial velocity of any time and you're looking for time, you're going to have to do a little quadratic magic. All right, so I'm just going to move everybody to one side, move everybody to this side. So then plus 20 equals 0. All right, and then you can either use like quadratic formula or you can use your calculator if you know how to do that. I don't know how to do that. Well, I know quadratic formula, I just don't want to do it. I'm going to put it into Desmos, okay? So you want to put it into some kind of graphing thing or use quadratic formula, all right? And then most often what happens is something comes out, one of the times comes out as negative, right? So that then it doesn't matter, okay? Because you can't have a negative time. All right, so when I look at this, I'm going to get a time of 3.73 seconds. Okay, so go ahead and, do whatever mathematical magic that you need to do. All right, once I have that, now I know my delta x is going to be v naught x times t, which is going to be 15.3 meters per second in 3.73 seconds. 3.73 times 15.3 Okay, and then I'm going to see that the ball will travel 57.1 meters. Okay, so no, not even close. Poor golfer sucks. Did not even get close to the green. So more like, doesn't make it. Okay. All right. And that's almost always the same pattern that will follow. Okay. Let me check out number 2 and see what it says. I hope it's solving for something different. Oh, yeah, initial speed. Okay. All right. So let's try number 2. Just touch harder, I think. Okay. A soccer goal is 2.44 meters high. The player kicks the ball at a distance of 10 meters from the goal at an angle of 25. The ball hits the crossbar at the top of the goal. What is the initial speed of the soccer ball? Okay, so whenever you see initial speed of the soccer ball, then you should be like, oh man, this is not good, because initial speed is harder to find. Okay, so I'm looking for this V naught. At least they gave me the angle. That was kind. 225. Okay, the goal is 2.44 meters high. Okay, and the guy is 10 meters away from the goal. Okay. What is the initial speed of the soccer ball? Ugh, brother. Okay, so we don't know these components, but we can just write them like this, because I know that they're going to look like this. I just don't know what number to put in for the V naught, because that's what I'm going to solve for. Okay. All right, so we don't really know what to do, so we just trudge on. And I guess I'll set this way as my positive again, up. So I'll have my delta x as a positive 10. Okay, my delta y is a positive 2.44, right? Because that ball is going to go like into the crossbar. Okay, and it might not, actually, that's probably not good. It might be sort of like on, like on the way up, like it would have continued, right? Or it might be like it already went up and then it went back down like this. You don't really know, okay? And the cool thing is it doesn't matter, right? Because the delta y is 2.44 no matter how it gets there, okay? Oh, man, I don't know anything. So I don't know the time. And I don't know the V naught x. I just know that it's V naught cos 25. And then my V naught y is V naught sine 25. Okay, and I know my acceleration is negative 9.8. This one is 0. Okay, so now I'm kind of hating life because this looks like a real giant hassle. Okay, so the thing that's the same between both, right? The time is the same between both, and the V naught is the same between both. Okay, so as you can see here, we have 2 unknowns, right? Which means that we will require 2 equations to solve for it. And lucky for you, we have an x and a y. Okay, so that's probably where this is going. So let me change color so I don't get scared. Okay, so my x direction, okay, I'm just going to set up my delta x equals v naught xt. All right, and then my y direction, I'm probably going to have to use this, even though I think it's going to be a complete nightmare, like that. Okay, because that's all I've got. All right. So what you want to do is you're going to have to smash these 2 equations together in some form, okay? Now, we can do it in variables. Is that going to be horrible? Let's think. I don't know. Let's see. Okay, so I think the easiest thing to do would be to think of putting this, right, into here. All right, even though that's going to be really ugly also. Man, I don't like this problem. Why did I give it? All right. Well, let's just see what happens. So delta y equals 1/2 a delta x over v naught x squared plus v naught y times delta x over v naught x. Okay, so I'm just substituting in that time. All right. And then in this case, it looks like I'm getting rid of the time, so I'm going to end up solving for the v naught. Oh, then I can solve for the v naught directly. I don't even need the time. Okay, now we just have to do some mathematical wizardry and get this to work. All right, so I think I'm going to go ahead and start putting in some numbers. Okay, now you're going to have to be really careful of your positives and negatives here. Negative 9.8. Okay, and then I have 10. I'm just going to leave out the units because this is kind of a nightmare. V naught. Actually, I'm going to get a number for that too. Okay, V naught cos 25, that's a number, so I'm going to just put that as a number, I think. Cos 25.91. Okay, so I'm going to put 0.91 V naught squared plus, I'm actually going to write this down here because I need more room. 1/2 negative 9.8, 10 over 0.91 V naught. You know, I don't even have the answer to this, so let's just hope that it's right. Okay, all right, plus V naught Y, so let's get a number for that sine also. Sine 25 is 0.42. Okay, 0.42 V naught, 10 over 0.91 V naught. Oh, well, that was convenient at least. Thank you for at least canceling that out. Okay, now we just have to, you know, your years of math skills are going to pay off. Negative 4.9. I'm just going to leave this for now. V naught squared. Okay, and probably instead of me watching me do this, you should probably be doing this. Oh, I can clean that up, right? You should probably be doing it, and then let's hope we get the same answer. When I do it live in class, we'll see if we get the same answer then. Okay, and there might be an easier way to do this. I don't know, though. Usually when you have to find the initial velocity, it's a giant hassle. 4.62. All right, well, okay, good. Well, at least it's going to come out positive, so that's a good sign. Okay, so let me move that to the other side. So I'm going to have negative 2.18 equals negative 4.9, 10 over 0.91 V naught squared. Okay, I'm going to move this 4.9 to the other side also. Okay, I mean, and this is just cranking out the math, right? You guys can do this by yourself probably. All right. Oh, God, I hope this is right. Okay, now I'm going to switch these guys around. All right, just switch these guys around. And 0.91 squared. Okay, so 0.83 V naught squared equals 100 divided by 1.4. 227.3. Okay, divide. Okay, and then I'm just going to take the square root all in one step. Okay, so 227.3. Aren't you glad I didn't put this one on the website? I better make sure they're not this bad on there. Then you're going to kill me. Okay. 16.5. Ooh, that seems reasonable. Let's go with it. Let's hope it's true. Okay, so my V naught is 16.5. Okay, so now that is the, that's the V naught at the angle, right? Because I've already, like, it's not the x or the y component. I've already dealt with that in the rest of this. Okay, I'm going to get rid of this part. Okay, all right, that seemed all right. Not that bad. All right, so when you're solving for that, it's much more difficult, all right, than the other ones. Okay, yeah, so there you go.